Atomic radius. The atomic radius of a chemical element is a measure of the size of its atom, usually the distance from the center of the nucleus to the outermost isolated electron. That is because an electron does not have a discrete boundary. There are various non-equivalent definitions of atomic radius, such as van der Waals radius and covalent radius. And then, for the atomic trends of atomic radius, an atom gets large as the number of electronic cells increase. Therefore, the radius of the atom increases as one goes down a specific group in the periodic table of the element. So the size of an atom generally decreases as one moves from left to right for a certain period. In general, the atomic radius decreases across a period and increases down a group. And then the Franciscus has the largest atomic radius, while helium has the lowest atomic radius. Then the ionization energy. The ionization energy is the quantity of energy that an isolate the gaseous atom in the ground electronic state that must absorb to discharge an electron and resulting in a cation. For example, hydrogen gas become hydrogen positive gas plus hydrogen negative. This energy is usually expressed in kilojoule per mole of the amount of energy it is take for all the atom in a mole to lose one electron each. And that, in general, the further away an electron is for the nucleus, the easier it is for it is to be exploited. In the other words, ionization energy is a function of atomic radius, and the larger the radius will make the smaller the amount of energy required to remove the electron from the outermost orbital. And then for the example, it will be far easier to take electron away from the large element of calcium than it is would be from one where the electrons are held tighter to the nucleus like chlorine.
Okay, the third is electron affinity. So, electron affinity is the amount of energy released or absorbed by a gaseous atom if the atom captures one electron to form a negative ion. So that's why if the electron affinity value is negative, so if it is negative, it means that it is easy for an atom to capture electrons. While if the electron affinity value is positive, so it is positive, it means that it is difficult for an atom to capture electrons. Now, so what is important to remember here? So the important thing is in the periodic table of elements, in one group, the electron affinity decreases from top to bottom, while in one period the electron affinity will increase from left to the right. As we know that actually the electron affinity value is not absolutely regular like that, but this provision only applies in general. So the elements that are easiest to capture electrons are group 7A. So the easiest is group 7A, or we call it halogens. Why? Because to achieve stability, group 7A only needs one more electron to reach group 8A, or we call it noble gas. So meanwhile, the element that is most difficult to capture electrons is group 8A, because as we know that the electron configuration in its subshell is the most stable. And next, we go to the third property of periodic element system, that is electronegativity. So electronegativity is the ability of an atom to attract electrons in a chemical bond. So the important thing to must remember is that on the periodic table of elements, we must remember that in a group, the electronegativity will decrease from top to the bottom. Meanwhile, in one period, the electronegativity will increase from left to the right. So we must remember the note. So the same as electron affinity, the elements that are more electronegativity or attract electrons are group 7A elements, or we call it halogens. While group 8A elements, because their electron configuration is stable, so that's why it doesn't have electron withdrawing properties. So from our discussion earlier, we can conclude that something like this. So we must remember, for the atomic radius, the further to the left and the further down, so the greater the atomic radius. While for ionization energy, electron affinity and electronegativity, the opposite is true, namely the further up and to the right, the value will be greater. So we must remember about these notes because this is so important in learning element periodic system. Thank you.